Hello and welcome to the first CentralByte for the IT Central CCNA CCENT Cisco 200-120 series. This particular CentralByte is regarding encapsulation, which, if you'll see here as we get started in this CentralByte, being a quick review of something, encapsulation is the process of wrapping a header, header and or a trailer around some data. It's really that simple. It's not really too much to explain on that. The definition has been sought over so much that it can be, confusing to some people. Basically, where we stand with this is encapsulation is a behind-the-scenes entity that the TCP/IP or even the OSI model did/do regarding pushing your request, whether it's a web browser, a file, or something. Everything has to go down the stack. We'll just say stack for reference or model for reference, meaning either the OSI, Open Systems Interconnection model, or the Transmission Control Protocol, Internet Protocol model. Either one, we'll just say stack or model. Your data has to go down, which is the process of encapsulation. And you also have the reverse of that as it gets to the other recipient, be a person or a system automatically, you have the reverse of that called De-Encapsulation, which is really the process of unwrapping the header and or trailer around the data. And then they go back and forth. So that's the basic synopsis here that we're going to talk about real quick. So I'm going to go ahead and erase the definition, if you will. I've already taken the liberty to put the respective stacks up here on the board. Out to the far right, you'll see the application, presentation, session, transport, network, data link, and physical. Those are all covered in brevity in Chapter 1, and I think partially the intro in the ICND 1 book, the 100-101. Sorry. What we're looking at here is the comparison. So this is the OSI model, which most people are more familiar with naming convention-wise. Then we have the former and the latter, the newer version or reference of the TCP/IP stack. So you have application, which encompasses application, presentation, and session. Transport stayed the same. Then you have network, which essentially has stayed the same minus the naming convention. That's why out here to the bracket, in the parentheses, you have I for internet. It did the same protocols, the same RFCs and stuff like that. Everything was the same except for just the name. The next thing was data link, or DL as I abbreviated here, and physical. Those are your bottom couple layers. They were in the former version of the TCP/IP model, they were called the link or the link layer. In your book, if you flip back to page, it begins around 20 and it carries forward from there. You'll find the different meanings and things like that of the layers and the variations therein. So you can refer back to that if you have any confusion with that. So we don't want to get too far into this. I only wanted to mention these to say that for this example that I'm going to teach from, we're just going to reference just the OSI model since most people are familiar with that, and because the layers of the TCP/IP stack most commonly match up with that, and I guess that was their purpose. So what I'm going to make a quick example here is, let me back up just a hair. With the example, we're going to use a PC. We're going to call it Bob. And we have a file server. A lot of places use Larry. I don't want Larry. We're going to go with Tom. Okay? So you got Bob and Tom. The standard process, I'm just going to use an arrow just for brevity. You have Bob sends a request, or a request or multi-request to Tom, and if he acknowledges it, like he's online, he has an IP address, he's connected, assuming all those things are obvious here and implied, he'll send an acknowledgement back. This almost looks like a creepy clown or something. But basically where we stand is he sends the request. Everything that comes down the stack is encapsulated. So you want to go to, let's put it in context. I'm a big context person. You want to go to google.com on your computer. So you fire up the browser, you type in google.com. We're at the application layer. Well, not physically, but logically we sit above the application layer, and the computer will interface. The application layer serves as your interface or your liaison between the computer applications that can use network resources like the web and file sharing programs or whatever. They interface with this and they move down the stack accordingly. So let's just say for brevity, you send your data by going to google.com. It goes down the stack, and we'll get to that real quickly in a moment. And then it goes, that's his request. He says, get homepage. Now this is purely looking at it from a technical aspect. If you want to look at it in that same context with me, you can back up in your text to page 24. This is where it explains the protocol mechanisms. And I'll just read it. You got web server Larry, or Tom as I'm using, and web browser Bob. So they're using the get home.htm. So you can compare that up with the video here as best in an analogy here. So he says, I want Google. So we'll just fire up this and say Google. By the way, no express consent for Google to sue us. Yay! No, we're just using Google. No partnership, whatever. So Google, you want google.com. So it goes down the stack. It encapsulates. Goes across. He says, hey, can I get your homepage? Now this all happens in a few milliseconds or seconds, depending on your connection or performance of your computer. It says, yeah, here's the homepage. Now there might be certain sequences or chunks, and we'll come to that real quick. He says, yeah, here's the homepage. If it's multiple things, like a big, like Facebook or something like that has lots of data, behind the scenes is compiling those in sequential order, saying here's part 1 of the order, part 2, part 3, part 4. So you got buffering and padding, which is a whole nother topic. It definitely wouldn't fit into a CentralByte, or maybe span across a few bytes. But anyway, so he sends back the request. Hey, here's the data you wanted. Okay. So with that said, all that to say and to set the stage for this. The example I'm going to use really quickly is that of, hopefully the orange will work. Not bad. What we would like to explain as the central point here is everything that happens at each layer, top, bottom, up, everything is just clumped together and called data. So the GET request, the HTTP, Hypertext Transfer Protocol, HTTP, the protocol says get homepage. Okay, that's really your data. So get homepage. We'll just call it home. Okay, we're going to zoom in just a little bit. So get the homepage. This is at the application layer. Okay, what we're going to do now is convert this to green. So get home. This is what we would call the data. Okay, that's the data that's being pushed down the network. That's at the top layer at the HTTP request. So remember, get home. Alright, so from here out, just like the aforementioned statement, we're going to use the reference of just data, which implies everything from the layer above put together in the encapsulation process. So we're going to say data. That's going to be the first portion of this here. So we move on to the next portion, which is data. The top 3 layers, you can just call them data. Okay. The way that I learned, I think either an acronym or mnemonic way to say it is data, 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 segment, packet, frame, and bit. So application is data, presentation is data, session is data, application, presentation, session, data, data, data. And then the more common ones that you really need to memorize are application, presentation, session, segment, packet, frame, and bit. Okay? DDD, SPFB, data, 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 segment, packet, frame, and bit. A lot of people don't even reference the bit like you do the data either, but they're all important. So this is the phrase that I learned in school, is just to simply write it down several times in this single alphabet letter format, and then fill in the words until you just memorize it and you can say it in your head alongside. So when I think application, I instantly know, kind of like speaking a foreign language, you just learned that hola, you just second nature know that that means hello or your greeting or whatnot. So I use that same mentality here. When I think application, I think data, presentation, data, session, data. Then for those who still need help learning, you say transport, you're sending the data, session or segment, you're segmenting the data. And then the most common one everybody knows is network. You hear, networking this, networking that. So you got packet, and then the data link layer puts it all in a big frame. Just take a big picture frame, put your stuff on the wall. And you got bits, which is the individual data, whether it's electricity or light or Wi-Fi frequency, whatever it might be. So remember this, data, 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 segment, packet, frame, and bit. That's the important part to remember right now. Okay? So what we're going to say here is, now that we have the first three layers, we have data. Remember, in the TCP/IP stack, it's just one big data. All these things that I'm showing you are OSI model. So data is then sent down to the next line. So we got data again. And this is where it gets good. Now you have to go in. We're going to go ahead and write the rest of them for data, data, 1, 2, 3, 4, 5, 6, 7. Alright, so we have data 7 times, crooked of course, down the board. This is where the video, the central crunch, can come to. So if you wanted to fast forward to this point, this is just fine. So your data remains just pure data all the way down the first 3 layers. Then you add the specific header related to the transport layer. So we're going to call the specific protocol is TCP, Transmission Control Protocol, TCP. So we're going to say TCP. Okay? TCP. Now, you can use boxes for this here, and I'll come back to those in just a moment. So you have TCP. It encapsulates this header, or the front, and puts that alongside with the data. Then we'll go ahead and do the boxes, because that'll make life a little bit easier. So we're going to ignore the boxes up top. Each of these down here is going to have its own box. Okay? Then we're going to add TCP in here. Okay? This is where it's going to get even more enriching for you. This is where it gets good. Take out that first line. This is the quickest way to learn this. Go ahead and erase data. And we're going to call this the new data. Hopefully you're not lost yet. So data, the original data is now replaced with a bigger, broader version of data. Okay? Now we're going to branch out and put the next layer, the network layer. It's going to get its header, Internet Protocol, IP. So now we're going to put that box in here. We use a dash to indicate. This here is saying, tack on the header that way. Alright, so next, you're probably following along now with how this is going to flow. So we'll remove these next few. We'll go ahead and input data again. Data. Okay. We'll go ahead and section that one off to match up with the IP level. Alright, this is where you get down to the data link. Okay, this is where you get a trailer. So we're going to go ahead and write data again. We're going to go ahead and put the header. So now you get the link header, and off to the side here, back up just a hair. This is where we're going to put the link trailer. Link trailer. So this one is kind of like the trailer you tow along in the back of your vehicle. So that's the quickest way to remember the headers versus the trailers in this particular context. So now we have this, and we're going to denote that with our dots again. Put that in there. And lastly, you can assume this is your data. And this one we're going to expand it to include there. So the data basically grows, you know, like a fish that you feed or whatever. Your data grows, you add your header, transmission control protocol at the transport layer. Still with your data. You crunch those together, and then you send that data down to the next layer, which adds which is the network layer, adding the internet protocol header onto this. You take that and you crunch it once again. Then you move it. It moves down to the next layer, and you put on the link header and the link trailer as well. Then those three pieces really, they all get pushed down, all the way down as one big clump of data, and then it sections it off into the respective count of bits and moves it across the wire. Now, just for simple brevity, this process is reversed for de-encapsulation. So it reads the data, it breaks off the header and the trailer, in this case just the one trailer since that's the only one, and then it moves up, it grabs the data, and says, okay, this is meant for this destination on the network, and it will move it up across, it'll route it across, then it'll get to that area, and it'll say, okay, this is a web page. Alright, let's strip off the header information as well, and then you break down just to data. Oh, I've got the home page. And then guess what happens? This process repeats with the respective data, no pun intended I guess, with the respective content as we say, and it moves down the same logical process back across the network, back up to the requestee, Bob, and he gets google.com. So this here has been a kind of sort of short CentralByte for the Cisco 200/120 encapsulation. Thank you for joining.